Hello there, my name is David Tobon. I work for Huawei Technologies European Research Institute. Today I want to talk to you about European Digital Product Passport powered by OPC UA, AAS, and Catena X. I'm a mechatronics engineer since over 20 years, and since then I have been active in IC standards, most recently in the OPC Cloud Initiative as co-chair and at the Catena X Association in the Digital Product Passport Working Group and the China Catena X Internationalization Task Force. Last year, we accepted the invitation of Mr. IoT, Eric Banstedt, to join the Cloud Initiative. Here, we agree on common cloud reference architecture to enable customers' cloud mobility and decrease vendor lock-in. This is clearly aligned with the European Union's strategy of cloud sovereignty and the Data Act. Concretely, technically, we have several working groups from Metaverse, OpenAPI, MQTT mappings, and Web of Things. But today I want to talk to you about the OPC UA for DPP, dataspaces, and Catena X. Basically, we agree with Eric, we need global standards for global OEMs and local SMEs. And most importantly, now we will need them for global DPP as well. My department's main job is to avoid fragmentation of standards, ranging from 6G, AI, manufacturing, and now DPP. So the cloud initiative makes my job easy in its approach to the Open NATO Foundation, which is one of the biggest open source foundations in China. So why do we need battery DPP? Even a robot can get depressed with mountains of electronic waste and unrecycled batteries. We need to recycle, we need to refurbish, we need to reuse. But to do that, we need information how to recycle and how to refurbish. European Union has an idea and it's called the Digital Product Passport. Huawei Digital Power product line is one of the fastest growing inside the company. It provides systems for domestic, industry, and commercial applications. The European Union has been working on a Green Deal since 2015. How to refurbish, repurpose, and recycle batteries is a big, high interest topic. The ESPR provides a legal framework for eco-design and sustainable products, and the battery regulation has been in place since 2023. The ESPR and the battery regulation are recommending a DPP IT system concept. For that concept to become a reality, there is a DPP standardization request, and there is a Sensenelec JTC24 for DPP IT systems that is supposed to deliver harmonized standards for DPP. By today, we have the ESPR regulation published, which mandates a DPP IT system. The standard request is released. The Sensenelec JTC24 is midway, and it's foreseen that each battery above 2 kWh will require a DPP IT system. Since you are joining this talk, I suppose you have interest in the topic of data interoperability and the product lifecycle management that Industry 4.0 has to contribute to the DPP IT system. I'm not a lawyer, but I can tell you all these things will be mandatory after 2027. Many details and standards still need to be defined, but the DPP IT system can be foreseen as a massive IoT collection of complex battery data across the whole European Union. Product A, B, C, and D from disparate OEMs will need to be comparable automatically. With this, with the DPP, the European Commission is implicitly mandating technical and semantic data on interoperability. And this is where a big opportunity for Industry 4.0 and its standards can present itself. Just as there is battery vendors and battery manufacturers, there is digital twin providers. Thankfully, Manufacturing X program has recognized the disparate digital twin solutions, and recently there is a new initiative to work together for DPP and battery passport. It is important to understand the scope of JTC24. The scope right now is the IT platform. The standards of the DPP content inside the DPP ITC system is not worked on by the JTC24. JTC24 cares about the DPP system itself, and the content for batteries should come from the battery regulation and most recently from the battery passport project that map the battery regulation into a specification at DIN. Even though this talk is about the DPP IT system, we need to talk quickly about the battery DPP content. It is coming from the battery regulation and very specifically from the Battery Pass project in Berlin, which has mapped the battery regulation to 7 categories: the general battery information, the compliance levels and certification, the battery carbon footprint or PCF, the supply chain due diligence, battery materials and composition, circularity, resource efficiency, and very importantly, the performance and durability. So as you can see, for the live DPP, the most important category is the performance and durability, which need to be collected dynamically. Coming back to JTC 24, we see and we must find how the Industry 4.0 standards can be deployed to comply to DPP. It is very important to see that we have mature solutions for technical and semantic data interoperability, and the authorities will need to be able to compare in a trustworthy way data from different companies. For this, we have projects like Catena X, which are explaining the way to use data spaces for DPP. At the last COP29 Standards Pavilion, IC Standards Sustainability experts recommended two aspects of DPP, the dynamic DPP and the embeddable DPP. Dynamic runtime DPP for battery performance is foreseen to be read and write, downloadable to the asset itself, and uploadable to the cloud. This kind of live DPP can provide actual usable information. The embeddable DPP, it is foreseen to be that the core of the DPP should be embeddable in the battery management system. The core of the DPP should not permeate by superficial layers of modeling, and it should be as close to the source of truth as possible. The copy of the dynamic DPP can be stored in the asset itself and send copies to the cloud DPP as a service collector. Embeddable DPP will avoid DPP washing itself. All these ideas and aspects still need R&D and pilots. Very concretely, we have several standards and projects that can help DPP IT system. We start with open source product data identification in the ID link, the OPC UA, the asset administration shell, and the Catena X dataspace. All these can be considered Industry 4.0 results that can be leveraged for DPP. As Huawei, we have been participating in the projects of the PCF cabinet since 3 years, and we have also worked with Catena X to approach different vendors for batteries. We also can see that Catena X has the most mature battery pass application success story close to the market. The asset administration standard is able to connect data from ERP, MS, PLM, databases, and machine live data solutions. If we connect this to OPC UA as it was intended from the beginning, we can have a dynamic DPP via the AAS and into the Catena X and Manufacturing X data spaces projects. How is OPC UA a key standard for DPP IT systems? OPC UA is the runtime global language of manufacturing, oil and gas, and energy sectors. OPC UA is state-of-the-art modeling language for complex embeddable technical properties. It has a huge ecosystem and dozens of professionals and free modeling software tools. OPC UA has been part of the Asset Administration Shell Specification Section 7 from the very beginning. Embeddable DPP. From runtime asset to cloud instances, battery pass spec, DIN spec can be transformed into OPC UA core DPP companion spec. Such an offset file can run in the battery management system or in the battery gateway. Then, asset and cloud engineer can share DPP context with the cloud library, hosted at OPC Foundation, SESMI, and in the future, Open Atom Foundation. Dynamic DPP. OPC UA is a state-of-the-art semantically rich information transmission framework that binds to different protocols, MQTT, Kafka, and even TSN, while maintaining the semantic glue of the DPP. MQTT does not standardize the payload. You will need OPC UA over MQTT or Kafka. Live DPP IoT powered by OPC UA. Save money and effort by avoiding Modbus TCP cross-variable register mapping, which if you have any experience with that, is a huge waste of time. OPC UA is accessible. You can build your own if you have the skills. You can have very low computing footprints and most importantly, very low pocket footprint with OPC UA servers being available in Raspberry Pis under 200 euros. So how do we leverage PLM 4.0 and DPP 4.0 for battery DPP? To start, we have our static DPP from our battery type, and then we can have PCF study reports, environmental, social, governmental reports, like sustainability reports, and most importantly for our refurbishers, how to recycle, how to refurbish the battery. That can include mechanical drawings, electrical drawings, and many other type of technical information. Then we place the battery in the market. We generate a battery instance with a serial number, and then we must create a live DPP and a core embeddable DPP. For that, we can use OPC UA and its rich semantic framework that is proven in the market for over 20 years. In our battery, we will have a core DPP running embedded in the OPC UA server, and which can be collected by dataspaces like Catena X or Manufacturing X. Surpass One research project foresees a federation of data spaces as the way to scale up DPP across the European continent. Catena X is the first successful commercial data space project that leverages over 53 standards, in many cases to curate IT tools, but also information models as the one from the battery pass. This is a very positive type of industry self-regulation of data. If DPP 4.0 standards, digital twin standards, can be leveraged inside the Catena X data space, we can have a very strong technical standards. Most importantly also, if we want to scale up DPP, we need a lot of IT outfitters that need to work with cloud suppliers on DPP as a service, interoperability, and application standards. So that is why it's so important for the cloud initiative at the OPC Foundation to have a cooperation with the Catena X data space project. The concrete next steps in Catena X are clear. At the moment, we are only looking at the static DPP model via the SAM, Semantic Aspect Models at the Eclipse Data Foundation, and Turtle files converted into asset administration shell submodels. However, to generate live and embeddable DPPs, we need to include the OPC UA standards. We can plan for live embedded DPP IoT pilots powered by OPC UA. In that case, we can add to the DPP use cases runtime behavior collection of the batteries, performance and durability, state of charge, state of the health collection, as well as, very importantly, the negative events of the battery itself. Catena X and OPC Foundation Cloud Initiative can really benefit for each other in joint work. Catena X has demonstrated how to apply the data space principles from GaiaX and IDSA into reality, as well as maintaining industry core digital twin registry and Eclipse Data Connector discovery services that can be deployed anytime in any company. OPC Cloud Initiative can help several cloud suppliers prepare DPP as a service standards to allow users to move across clouds and port their applications to different vendors. To combine the technology of Catena X and OPC Foundation will give a sneak peek on the future of DPP IT system. These are my conclusions and next steps. The DPP IT system, inspired by the ESPR and the battery regulation, will mandate technical and semantic data interoperability. This presents a big opportunity for the Industry 4.0 standard stack. OPC UA is a natural and powerful solution for DPP IT system. DPP 4.0 can solve those challenges if we work together. AAS powered by OPC UA is a much stronger solution that can round up the DPP 4.0 offerings. DPP 4.0 standards and open source are vendor-free technologies that can be globalized via projects like Catena X and Manufacturing X. Next steps, let's work together, better together for DPP, and let's plan pilots inside Catena X data spaces for live IoT powered by OPC UA. Join the work, and thank you for listening.